Start. Okay, cool. Welcome everyone. Thank you for joining. Today's session is led by Alexangel. He's working on system design for autocomplete. So I have no idea about the system at all. So this is new for me as well. So without further ado, Alexangel, this is your stage.
Yep, thank you, Manoj. Yep, okay. So today we're going to look at the system design for autocomplete feature. This, you all would have seen this mostly in, I think this screenshot shows, this is a Google one. As you type a word, you see the related terms. Or if you go to Amazon, you try to enter the product name, it shows up all the top 5 products or 10 products, right? That's what we're going to do the system design on. I think it's a pretty much system design plus a data structure related problem for the system design interview. So let me go ahead and start here. So this is high level requirement, right? Like either when searching at Google or shopping on Amazon, as user type, you show the relevant search terms to be displayed to the user, right? So couple of high level scope, right? Like if you look at it, how do we want the search term to be matched, right? Do we want it from the beginning, like as I type for example, uh, SAN, we want to show the San Fernando Valley, all those starting with it, right? So we will look for a one starting with, and then the number of suggestion. Here, I think it displays a lot of them. Probably we can limit to 5. Um, so also, how do we figure out what terms to show? What is the criteria? What is the criteria? Is it like based on the popularity of that term or popularity of the search, say based on number of time people searching for that. If it is a Google, probably it would look at the number of times people are searching for that particular word, that becomes a popular word, right? So we need to sort based on that and show them top 5, right? Top 5 search terms, right? um, so on the scale wise, I'm just put it just to at a smaller scale. Obviously Google should be at a high level, so I'm looking at 10 million daily active users. So given that, we can do some high level estimate to see how it's going to be working, right? So that way we can design the our database model and then the application tiers, right? So if we have a 10 million active users, um, for example, each user does a 10 queries per day. Say as I type, um, if in this example, right, as I type S, it would bring all the related 5 terms from the S, and then from S I type A. For SA, it would get similarly. So with that in mind, if we look at it, we end up sending the queries like a 20 queries for each search term. We are sending 20 queries to the backend to get the results, right? Are you guys with that? So given that we'll be executing 2 billion requests per day, that if we count it, it's around 24,000 QPS queries per second. This is a high level estimate, right? So given that, so we need to look at the components, like what are the components to build this auto search or auto completion feature, right?
Can I ask one question? How did you come
Yeah,
up with
sure.
what was that calculation for 20?
20 is the number of times, right? Like if I'm going to search the entire word, obviously I'll be for S one time, for A one time, and for N one time, right? So it's 3 times. So I've just average it out 20. It could be 5 if
Got
it
it,
is
got it.
smaller, right? Yeah. Or I could switch this one to say number of person querying is 20 per day, and then maybe 10 queries. So if it is only a smaller word, right? Most of the time, maybe the word could be smaller or bigger, right? So we can switch it that way. Does it make now? Does it make reasonable approach for this number?
Yeah, no, I was just trying to understand how that number
Okay,
came
yeah.
about.
Yeah. So number yeah, that's the reason I was looking at it so we look at it it could I could keep typing, right? Then for each and every instance, it's going to bring top 5 items, right? That's the
Got it, got
reason.
it.
Given that in my mind, in order to build this system, we have to look at two areas, right? One is by looking at this requirement, we need to build the data model to store the top popular items, right? Like top 5 items for each and every letter, or each and every letter combination. For A, what is the letter combination? Like say, for example, if in this example, for S, we need to get top 5. For we need to get top 5. Like no, like that, we have to build this data model. We have to build a database to store that. Also, we need to continuously update that one to um, system. That way, we can, when we search for a particular term, we can get it from there. So one is high level. We have a component to do the data ingestion service. Let's call it data ingestion service or a data collection service. And then second one is a query service. This is responsible when you type the word, it goes and gets it from the system, right? Like, what are the top 5 items for each and every term or every word or every character, right? So let's look at the how we are going to build this data model, right? Like, let's see. Let's look at a couple of options, like two options. One is, for example, when I'm typing Twitter, right? T, I need to go and get top 5 items starting with T. W, I need to get top 5, right? The one way is we can look at RDS to store it. Like, for example, let's consider RDS, right? We store that in a table with a query and a frequency, right? Like in this example, we have Twitter, the frequency is 10, like Twilio 20, Twin 30. That means the highest search term is Twin, right? So when somebody types, I need to get T, starting with T. In that case, I'll be getting the Twin first. And then the second item would be Twilio, third item will be Twitter and Twitch, right? Based on the frequency, right? Are you guys in line with us? Like, no. Oh, okay. So this, if we store this in RDS, right? The one of the drawback with this approach is, say I have 1,000. Here I have only four words, right? Say I have like a Google, I have like millions of search terms. So in that case, the way RDS table is going to work is, as I type T, I'd be writing a query, like let's call it like query, frequency table, right? Word frequency table. I'd be writing select star from word frequency, where query term like T, starting with T, and then I'll be executing one for WTW, right? So in that case, it would be doing a table scan on the entire, like if I have 10 million rows, it would be doing a 10 million table scan on the 10 million rows, and then it will try to get all words starting with T, and then it takes that, and then from there it would sort based on the frequency and gets it. This would be pretty expensive query for that. RDS would definitely won't scale that well if we try to run it on live queries. So that's where initially we talked about, right? Like, this is more of a data structure problem as well. This is called, there is a structure called try. I think it comes from a word retrieval, try, or some people call it prefix tree, right? So prefix tree is nothing but a tree, like where you have a top node is an empty node with the root, right? And then for each and every character, for example, in this requirement, what we are saying is we are only having 26 characters, lowercase 26 character. We are going to use it for all the queries, right? So the way it stores is you have a top node root, and then for each and every character, you would have a um, same type, like you can see here, right? Like in the try node, and then here you can see try node as a self reference to this one, like 26 of them, right? So the way you travel is you come to the root, say I type T, then it will come to the root. It will look for either a T is there, like if it is not null, in this case, like you take the children T dot children of T minus A, that will give the T's location in that array. If it is not null, okay, say I type T, so then it will take the words, it will go and find the words below that and sort them and return, right? For example, I start with T, it would go T, and then it would go all the paths and then try to get what are the words. In this case, we get tree. This is a complete word, tree to toy, right? So and then it would start based on the frequency. In this case, true would come in the top because true has the most frequent word used. Second would be toy, and then tree, right? If we look at this time complexity for this approach is you are basically right away going to the T, right? So and then the length of the word, right? Like no. So in this case, like no, we are going up to tree, two, right? Like no. So the length of the word, and then for sorting, we are doing a log L time. Um, that once
Sorry
you
to
cut.
interrupt. Actually, you are like in your data structure class try node, you have like a is word, right? So do you think that should be a like frequency or something along with it?
Oh, yes. Yeah, I put the structure how it looks like. Yes, definitely. We should
Oh,
have
okay,
the frequency. Yeah. Yeah.
okay.
You're right. Absolutely right. Yeah. So I just people, if they haven't used it, they just put the structure on it. Definitely,
Oh, okay.
it's a valid point. We should have that this one. So still, if we look at the performance wise, it is far better than this, but it's not good because you have to go once you find the T node, you have to go all the children of T and go till end, get all those words, and then sort them, right? So this would be a L times L log L. Can we improve further, right? That's one approach we need to look at it, right? Because we are doing the length of the string. In this case, the max length will be 4 letters. Most of them are 4 letters. And then you have a log L to sort them out, right? So instead, we can this tree could go further also. Like it could be height of the tree could increase also, right? So there is the alternate approach. What we can do is we can modify this try node a little bit better. The same example, right? Like no, I have a root node. I'm using a different word. I should have used the same word to make it easy. So what we can do is say as soon as you go to B, at the B level, we could store the top 5 items. Say, for example, we agreed on displaying top 5 items or top 3 items. In this example, top 3 items, right? We could store it at here. As soon as you go to this node B, you would know as I type, as a user types B, you go to the root, take the root from the root, you find out B is there, B is there. Yes. Now, what are the top words? We could store at this level. Somebody pointed out the same thing, right? Like, no, we could have the this combination word with the frequencies stored here in a sorted list. Instead of having a val, we could have a one more thing called public set or a sorted list with the combination of word and the frequency, right? So then we can immediately get it. This would be a time complexity of O1. So this will be faster, right? Similarly, and then once you type BE, it goes to the next one, it gets it, right? So this will be faster. You don't need to go to all the children node and get it, right? So this is the data structure is used to do the prefix tree. We will come back like no. So how we are going to store in the database like no. We'll come back like no because we are not going to have a one single server holding the entire prefix tree. That is not going to scale well. Also, if it is in the memory, it goes down for any reason. We have to rebuild it. Like no, I don't know how we can scale that one. So we have to look at alternate approach to persist, also to scale, right? There could be thousands of words or millions of words. Like no single server cannot handle. We cannot replicate the same data to each and every server, right? So we'll come back
I
and look at it. Sorry, go ahead.
I have a question, and if you're going to answer that later on, just let me
Yeah.
know.
Mhm.
How do you form sentences here? Because if you have sentences, right? It just the try seems to be very deep to me in that case. For example, best phones to buy, best batteries to buy, best earphones to buy, best etc. to buy, right? There could be like you could just have top five over there. How
Yeah.
does this tree work with sentences?
Oh, that's a good one. I never thought about it. Probably I'll do some research on that.
Okay, not a problem.
I was looking at the top 5 words. Yeah, definitely that's a good one to think
Got it.
through. Yeah. Or if anyone has idea, like, probably they can share it. I'm thinking we could
Don't
store.
deviate from your design. I'll keep that question on hold, and if you
Okay,
have time,
sure.
we'll come back to it.
Okay, sounds good. So let's look at, right, like, how we are going to build this, how we are going to get this data, right? As the user types, or as the any user, like, looking for that word, we are going to send from that application log. We are going to send it to a log. This could be a just append only log. It has the word and then what time they queried. So this log could be generated and sent to a more of log aggregator, which basically reads the log and then builds that, like, frequency table, right? Like, say, like we were looking at this table right here, like this, right? It could build a table like this, maybe in Cassandra or any of those right here table, and then we would store it in the try database and a cache. Let's look at that, how we are going to store this, right? If it is a word only, as Monil pointed out, I'm not going to talk about that multiple words like sentences. Rather, let's look at the words. In this case, we could go for instead of RDS, we could go for uh, like a DynamoDB, document DB, like more of NoSQL database. So in that case, we could store B and then the top five, like, say whatever the top three, in this case, top three items, right? We could store it key value pair, key, and this is the key and then value. So as when you want to look for a word BE, you just directly go to BE and get it. This DynamoDB, definitely the NoSQL, you can horizontally scale, right? That's the advantage. So
I
with
think
that in mind, we can
we
go for a
should
NoSQL database, and also we can store the same data in a cache to make it little more than faster. Like, it would be compared to the NoSQL, the cache would be in memory, so it'll be more faster than the NoSQL database discretes. So we could look at Redis kind of cache system where you could have a key, and then Redis provides a value. You could have a sorted set, I think. That way you can have the sorted values. You can just directly pull it there, and you don't even need to sort it. You can send it to the front end, right? So that's one approach. So as the data comes in, goes to log, and then aggregator does some work like aggregation, and then pushes to the try DB and cache. Obviously, this is not going to be real time, but the reason is most of the search terms are not going to change instantaneously, right? It could change next day or next week, right? So with that in mind, probably we can run this job like every 1 hour or 2 hours to build this data, keep updating those data in, right? So this the high level flow for the data ingestion system, right? Or a data collection, how we are going to build this TriDB and cache. Maybe every week we can refresh the entire Tri database and the cache also. The other approach we can look at it, right? So when it's querying the database, right? Like when you are going to the front end and searching for the terms, say from your browser or from mobile, it goes to the load balancer, and then we have a query service. What it does is it goes and looks at the try cache, look at it, is the word exist? If not, if that particular letter exists, if not, it goes to try DB, gets it, puts it here. So next, anybody looking for that particular thing, they get it from here. Obviously, we have to have some job here, which basically cleans up this, or we could have time to live, like, the expiry maybe a day worth, or like maybe a couple of days. We could keep it based on our system, like, requirement. We could probably clean out the data every, like, or some eviction policy we should set it here. That way we don't see the stale data. Okay, so coming back to the one of the thing we talked about, right? Like, we are going to put it in NoSQL. In order to scale this up, like, say we want to scale this, we have millions of records coming in. One single database won't be able to handle this one. I think here, one single database won't be able to handle this request. So what we can do is, when we are storing the data, we could have some short mapping. So we know, right, we have 26 characters, we are looking for only the lowercase letters. If it is more than, then you have to go for Unicode 128 characters, right? In this case, we are looking at 26 characters, right? In this here what we can do is we can, for each and every character, we can have one short or a combination of words. We could have some letters starting with A, B, C. Those things are large compared to words starting with X, Y, Z kind of thing. So based on that, we can shard this appropriately, and then we could have some shard manager which says, okay, this shard stores from letter A, starting with all the words starting with A to B, B to C, like that. We can put it. When the query service first initially looks at it, it asks the shard manager to provide what shard to go. Oh, it says shard one. It's because it's starting with the A. So you go to the shard one and get it, and you send it back that results. Um, Anything else I need to talk about? So that's the one way to scale this one up. Um, I know this is going to be a pretty short one. Um, Anything else I missed it, or any other questions?
What was the reason to build your own database? Like, why not Elasticsearch? Because Elasticsearch,
Mhm.
it will, it basically will generate a try. That's how I think its entire thing works. Its search indexes work. So I mean, try is not the only thing. It probably has a lot more things. So what was
Yeah.
the reason to um, use like your own try versus some text searching database?
I'm not sure is the Elasticsearch that does the top five and other stuff. Like if I want looking for a top five, I'm not lot familiar with Elasticsearch. Does it do
Yeah,
top
yeah,
five
it can,
items?
it can. It depends. It's a text search database, so
Mhm.
essentially the autocomplete feature is like inbuilt into it because when you insert, let's say if there is a field, right? In which
Mhm.
case it'll be a query, and you say that hey, this query is a text, so it'll basically index it, and
Mhm.
you can have a value associated with it. It does a lot of fancy things as well, but
Okay.
Forget Elasticsearch. It's essentially just a text search database.
Okay. Okay. Got it. Okay. Yeah. Maybe yeah, that would be alternate approach to do it. Yeah. If we want to build our own thing, like this is one of the other approach, right? In this case, you are building for auto completion. This would be one of the approach. Yeah.
Got it. Got it.
Yeah.
Okay.
It's a good point. Yeah.
Got it. Did you research that? Just curious about it.
No, I didn't do the research. Like
Got it.
no.
Got
Yeah.
it. Okay. Okay.
Yeah. Yeah. That's a
Uh,
good point. Yeah.
now,
So your question is basically why not Elasticsearch, right? I don't know.
yeah,
Maybe the underlying data structure could be the same thing. I'm not sure.
it probably
Um,
does. It probably
yeah.
uses combination of other things, and not just
Yeah.
Elasticsearch. Just my question was like, why specifically like build your own TryDB, right? Because you usually don't have TryDBs uh, for this specific, like text search databases are built for this. So that's why I was wondering
Mhm.
like, why build your own database?
Oh yeah. I think this one of the common system design question. I think mostly comes around in terms of the data structure, try data structure. I think
I see, I see.
yeah, how you want to build your own thing, then this comes in the picture.
God. Okay,
Yeah.
okay, fair, fair.
Sorry, I had a question.
Mhm.
I was wondering, so for analytics, would we need something like MapReduce or Spark? Like, how does that come into play?
Yeah, maybe in this area, right? Like, probably we should, if the millions of records coming in, probably we should have some kind of map reduce, which basically takes the data and then combines and builds that what are the top five items. That way we can push it to the each and every word. What is the top five item to the TryDB? Yeah, this would be a job which runs maybe in a nightly or every couple of hours. Did I answer your question?
Yeah, that's good. Thanks.
Yeah.
Thanks.
Another question: why does this need to be a batch job? Why can this not be real time? Because, for
Yeah,
example,
that's a two approach, right? One is yeah, that's a good point you brought it on, right? Like no, say like a Google kind of system or a large system where you have a lot of queries getting searched, right? So updating at the real time would be pretty challenged, right? Because you have like words starting with B could be millions of words, right? Like starting with B, right? Like um, so in that case, real time would be a big challenge. But there is approach I have seen. What they did is in the cache, like instead of going to the DB first, the way it was built is like as you query in this word, right? What they are doing is they load the cache. In the cache, like a Redis, right? It provides a sorted list. So as the term comes in, like you keep updating this sorted list, sorted set. I think the value is sorted set. You keep updating top 10 items. You as the new word comes, you keep updating it. Then you push it to the try DB. But still, I don't know. Like if the words are increasing lot, how do you manage, right? Like if you have 10,000 words, right? Like starting with B, how do you know which one getting picked up, right? That's going to be a challenge, right?
Got it.
Yeah.
One
Updating at the real time, I'm not sure. Like that would be a big challenge.
one comment there would be that if you're actually comparing or designing something around like Google, you definitely want it to be real time, right? Because for example, let's say an NBA game just got over and some team
Mm-hmm.
won. People are usually going to search within first few minutes to hours, right? No one is going to
Okay.
search after 2 hours. So you essentially that query should show up on the top, right? Now that need not be just based on there could be multiple solutions to that. One could be real time, other could be special events kind of thing where these things are flagged as special events and they show up on the top. But uh, I feel like it would be more close to real time as opposed to more batching. It might be a mix of two as well, but I don't think it will be pure batching for sure.
Okay, got it. Okay.
For
Yeah. So
Amazon,
what you're
batching might work actually, right? Because Amazon's relativeness could be based on multiple factors. Like one could be just search, and the second could also be a buy action. Because
but
as
okay.
an Amazon service, you want to show products that people are more likely to buy as opposed
Mm-hmm.
to just showing a relevant term, right? So for Google,
Yeah.
search count makes more sense. For Amazon, it might be the buy count along with search count, if that makes
Search.
sense.
Yeah. 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 Probably in that case, probably we should have a more of a streaming system somewhere here, which basically gets those and updates this database, right, on real time plus aggregated data, right? That's what you're saying. Is that right?
Right.
Yeah.
Now, let's say if we were to do that, right? And then now we are getting into like me asking questions as opposed to
Yeah.
going into the system you've designed. How would your database react to that? Like what could go wrong with your if we start having a real time system right here?
Okay. So one of the thing, right? Like say for example, all of a sudden the B word, right? Like for example, the B, we are getting all the new terms, whatever is not there, right? In a millisecond, that became a popular word, right? So in that case, we have to go all the way wherever it's B and then the related word starting. We have to go and update at real time, right? So how many it would be like, as the, for example, B, E, yeah, that should be faster, right? It shouldn't be a problem, right? As long as we are able to aggregate that word. Say, if I'm looking at, there are two scenarios, right? One is the aggregated data is for a week. This is at real time, like last 5 minutes, what are the top 5 items, right? I'm going to use that as my data. In that case, I can quickly update the cache as well as try_db, because as soon as the B would be one record, the next record would be only one more record. So if it is a 5 letter word, it will be 5 records would be updating in try_db as well as cache, right?
So who is
Right.
updating the count? So let's say the real time has some numbers. So a query comes in or a word comes in.
Okay.
The real time pushes it to try DB.
Okay.
Uh, who is updating the count? Is it TriDB that's updating the count in the cache?
No, here, right, like, no, so this aggregated data, like, no, this would be pushed to the TriDB. I think probably I don't need to put it here in this cache. I think this may be the wrong approach. The cache is more of it. Only if the cache is not there when you query service is the only thing. You're right, like, no. So this service, like whatever we are building here, the aggregated data here, and then there could be a service which basically updates this TriDB.
Go-
Say in this case, like whatever the number of words or number of, like, 5-letter mean, five character, 5 rows would be updated, 5 items would be updated, and then the caches get filled in as you query the data. It gets filled in. Right.
Got it. So this is the query side.
Yeah.
Got one question. So the TriDB that you have up there, right? That's basically holding the try data structure. So like it can actually traverse, like you said, right?
No, it is not actually. That's the thing, right? So try data structure, you build it. Now you know what are the words, right? And then for those, like, you are basically loading this here, right? In here you would be building the try data structure,
Oh,
but
I
this
see.
is a key value store.
Oh, I see. Okay. Sorry, I
Yeah.
missed that part completely. I
Yeah.
actually thought that your TriDB is a combination of something that's holding TriDB.
No. So
TriDB
you
is trying to
basically
say.
having a service which basically builds this, and then quickly it knows it can hold it in a memory, right? Like, you could have a try database more of a distributed, but that would be in memory. And then in order to persist, you put it in a key value store, right? Yeah.
Got it. If so, let's say if I give you BEST, right? Best. So the try will be formed for B, then BE, BES, and BEST, right?
Yeah.
Will all these 4 combinations be stored in your key value pair?
Yes. Yeah. B would be stored, and then BE would be stored. Yeah.
I see.
BES would be stored. BEST would be stored as 4 keys now. So in the B, you would go and update the best if it is the top item, right?
Okay, so when you're searching for B, okay, so if I search for BES, then you would still, like, best would still show up top on for all 3 characters, for example.
All that together, yeah. Yeah.
Got it. Assuming that it is. Okay, got it.
Yeah.
Okay. Do you mind if I ask more questions?
Yeah, go ahead. Yeah, this is helpful, like, so I'm also thinking, like, what are the things I'm missing, right? Yeah.
Okay, so how would we solve the problem if it was a word, sentence instead of a word?
So,
I feel like at that point you might as well just use like some kind of predictive search or some kind of ML model, right?
Well, but still, I mean, even if I give you ML model, it's going to spit out something, right? What is that something? How do you store that?
Do you like strip out all the formatting and make it like a continuous string or comma delimited of just words or something?
Can you expand on that a little bit?
So if there's like a sentence, you would like take out all of the white spaces and maybe have like one node on the try to represent maybe like a period that a new word is forming, and then the subsequent letters would be like continuing on with the same paradigm. Shot in the dark, but
got it. I like the approach. So let's talk about it a little bit more, right? Because I want to understand.
Can we look at this, Manil? Is it okay if we look at this example? How would they would have stored, right?
Yeah, exactly. Let's take a look at this, right? So, how do you get this list, right? Now, let's start with the ML model, right? We don't have to discuss how the model works or anything, but I'm assuming there is a list of input to this model, and the model is spitting out something.
Yeah, so I actually done somewhat something like this back in school. So basically you have your different engrams, right? And then you put that as your seed. So basically, whatever the user types in will be your seed of your like model, and then you feed that into the model. Of course, you will also do some stripping of white spaces and special characters and everything like that. But once that's finished, you basically put that into the model, and the model will spit out what is the most predictive phrases that comes after your seed.
Got it. And so now we have static responses, though, right? So
Sorry?
so let's say the model spit out this list, right? How do you store that? So how do you where do you store that list? How do you store that list, and how is that served?
Well, for the storing of that, well, I think the best way to do this is that with the first time that you actually search, or any user that search the term, right, or the phrase, it will actually be calling directly the recommendation engine or whatever model that you're spitting out the results from, and then that will be storing a cache somewhere, right?
Got it.
And afterwards, if any subsequent calls from any other users call it within a certain given amount of time, it will just spit out the same cache results again.
I see. And so you're training your model offline, right? And you basically have this model running somewhere online. I'm assuming that you're not like so when someone searches for SAN, the model gets invoked, which is the part of recommendation engine, and the way it was trained, it will spit out some words, right? Did I understand that correctly?
Yes, something like that.
Okay, but in the end, like it will still need the repository of the words, right, to form that sentence, or no? Even if the model is trained offline and then put online.
Well,
So-
it depends on how this model works, right? If you purely just want the model itself, you could have run it like some kind of like streaming service, and then it'll just not save any data, and then you'll also run the model training online as well. It just depends on how we actually train the model itself, right? But if we do want like a log of everything, search words, then yes, we also need to save it somewhere.
Got it. Okay.
Can I add something here? So, see, someone else mentioned, right? Like, probably we can look at the other approach would be, say, we are limiting up to 20 characters you can type or something, right? It could be multiple words, right? In that case, we can, in this example, right, SAN, and then we could put some delimiter and then FE, store that what are the top 5 for that. So we can keep up to 20 characters, right? Would that solve a problem if it is a multiple words, right? That's the other approach, right?
Maybe because if
You're only storing like here, right? Like 20 of them, like SAN, some delimiter FE, and then SAN FER, like that, right?
Oh, I see.
Yeah.
Well,
And
but
then
then
since
what ends up happening is, so if you have words, right, then it's fairly limited. If you have sentences, that's not very limited, right? It's a pretty huge data set. Like I don't even know how
yeah,
huge it would be.
yeah. That's why you're pretty much sharding, right? Probably if it is the most ones, like probably you could go with it's since NoSQL you can horizontally scale it. Probably A could be in one shard, which has all the A's starting with A, B, like that, right? Yeah.
But
Obviously it'll be a huge setup. You're right.
but
So how about a hybrid approach? Why don't we save the words and train a model? Because I'm pretty sure Google works in the sense that like if it realizes that you are writing a noun and then you're starting to write the verb, it will look into verb. So there's a model, there's a machine learning model behind it.
Yep,
So
exactly. No,
if we
that
store the words and we store the model, I don't know a lot of machine learning, but there is a model of like sentence structure and stuff like that, then we could assemble it from the database by putting the words together based on the model. I think that's how it works. I was thinking of something a little bit simpler, like creating a try from the words tool. So like you would save the words and you would also save another connection between them. But then that is not as intelligent as what I was originally talking about. Like you wrote a noun, you're starting to write something, it has to be a verb. Or like there's 90% chances of it being a verb.
Yeah.
That is actually a very key point. Whenever you design a system, not just for interview, and this is I learned this the hard way, or you're doing aggregates or you're doing this kind of suggestions, you always want to ask how much is accuracy important here, right? If an error rate, so the system that you have presented, alexangel, that gives you 100% accuracy, right?
Yeah.
Meaning what
Yeah.
everyone has searched for will always show up. But it has a cost associated with it, which is, you will, like, even if you form sentences, it doesn't matter if you create shards or anything, you will just have a ginormous database, right? You'll have, like, I don't even know how big it would be. That's where approximation comes in. So if an error rate is acceptable, that's when you start using like machine learning models, because they're not accurate, but hey, they will get the job done, and you will have a much smaller data set, and you pay a much lesser price.
Oh yeah, it's a good suggestion. Yeah.
So that is a question that that you should ask if you realize that, hey, this can actually get pretty big and it might be hard to handle. Just that like, hey, how much is approximation important? Like, can we tolerate some error rate? For Google, I'm pretty sure we can tolerate some error rate. Like, I don't think they need 100% accurate results.
Yeah, I agree with you.
Now let me ask you this: how would geosharding work in this case? Like, how would you do that? Right. So searches in US are different than searches in Europe, are different than searches in Southeast Asia. What?
Based on language?
Yeah, that's where you would go for the one thing we talked about, right? Unicode format rather than 26. Your try would have 128. I think it's a Unicode is 128, right? Like it would support all the languages around the world. I think it's 128. I think my understanding, 128 or 256. I'm not sure. So you try would have a instead of 26. This is only the lowercase letters. So in this case, it would support like 128. So you would scale your this thing across. Probably it should keep some charts in the different regions to support your users are coming from different regions, right? That's one approach.
So something I've noticed in reality, I think they actually cheat and they redirect you to their specific site for the location you're in. So they know exactly where you're in, so they probably know what server to, like, what language you're probably searching in and other things like that.
Exactly. That's not a product feature. That's a technical limitation.
Yeah. So they're cheating too.
Exactly. So you have google.in, google.de, google.pk, whatever, right? Different IT. Those are not to make it easy for you to remember that, oh, I'm in Italy, so I'm just going to use google.it. It's actually a technical limitation.
Completely unrelated, or not exactly. When I was in Europe, I was trying to search jobs on Glassdoor in America, and it was impossible. Like, you would have needed a VPN. It just did not let you do that.
Exactly. Okay, and anyone have any other questions? I'm actually out of questions.
I have a sort of generic-ish question. This was an algorithm-based system design. When is it the right thing to do? like sometimes I'm very tempted to go into something I know as opposed to what kind of, I mean, we've gone through that to what kind of database, but there was a lot of like talk about the data structure we're using and stuff like that.
It really depends on the interviewer, what they want, because, like, for example, let's say, Alexangel presented this. If I was doing it, if I said that, hey, and assume I'm in an interview, I would say, hey, I would use something like Elasticsearch or some text search database. If the interviewer did want to know how that works and my knowledge into that, they'd be like, okay, let's assume we don't have that database, or can you explain me how this would work? And basically get into this detail. So it really depends what they're trying to gauge. Most of the time, sorry.
Oh, sorry. I just wanted a clarification. So would Elasticsearch be a piece of the puzzle you can just throw in there and say that I would use Elasticsearch, or would you have to explain how it works, which I actually don't know?
But it would really depend on how again how they where they want to dive in, right? So uh, you don't want to, like, if you don't know what Elasticsearch is, I would not like say, hey, I don't know how it works. You would just say that, hey, well, you would say that, but it doesn't mean it forbids you from using Elasticsearch. You can just say that a text search database, I think, would be perfect for this case. I don't know how it works, but we can try exploring that if you'd like. And if they don't want that, they will usually say, no, that's not what I'm interested in. Let's actually go forward and let's assume we can use Elasticsearch. Or they might say that, yes, I want to know how that works. Let's see what we can come up with. And then you're going into this. So it really depends where they want to take the conversation. If I was asking this to like a staff engineer or high senior, I would like to know more about like cost. I would like to, like, how are they, what are they assuming about the cost? What are they assuming about the real time system? Like that thing that I said that, that an assumption was made that it's okay for it to be 2 hours late, but that's not really true. So I would have asked them that. Geo was another thing that I would expect them to come up on their own. That, hey, this is a geo database, so if we have it in Malaysia, if we have it in Singapore, this is how I would do it. One thing that alexangel did cover was different Unicodes, so that was another thing I would be looking for. But if it was someone who was senior, then I would expect that I would probably dive more into data structures. Not to say that for staff engineers or higher seniors I wouldn't. I would just ask them, not get into too much detail. I would be like, how do you think Elasticsearch works? How does indices work? Just to get an insight if they know it or not, right? Or can they think about it? If they just say that, oh, I have no idea and have to read it up, then I would start diving into indexes and partitioning, right? So it depends. Like you want to get the signals as an interviewer. They want to get signals into how deep can you go into a topic and which topics are hard for you. Again, there's no point going into regions that are not related to your job. Like if you're not working on processing processors or something, I wouldn't go there. But if you're doing multi-threading or if you're doing distribution of data, then that's what I would focus on. Does that make sense? Does that answer the question? Unfortunately, there's no like clear-cut answer for that.
Yeah, this is really good point you brought it up. Like, even I didn't think through geo database and then multi sentences, right? Couple of scenarios. Yeah, those are pretty valid points. Yeah.
So here is something that one of my mentors told me, right? And I when I was 6 years into my career, I wrote a design document, my first design document, and my mentor was like, "This is garbage. At your level, you're supposed to sweat the details." And when I said sweat, I wrote that design document 4 times, but now I know what sweating the details means. So like you should go into as much detail as you can about every little thing. And that's what in systems design they try to look for, right? Like, are you thinking of all the details? Are you thinking about all the edge cases? Unfortunately, it's very hard to do it in 45 minutes, but
Yeah,
yeah, but you have to show signs of sweating the details. So always remember that. Like, just try to sweat the details. Don't try to gloss over situations. Even if you don't know about it, don't try to gloss over it, because the interviewer might think that you are actually not sweating the details. They might not know that you're trying to escape the situation. So instead of escaping the situation, just say that, hey, I want to dive deep into this, but I am not very sure about how Elasticsearch works. I have never worked with it, but I think the use case fits well. And you already set the tone. You don't know. Now, if they really need you for Elasticsearch, they should not have interviewed you, because you don't have that on your resume. But most companies don't look for very specific tech, at least the big tech companies. So I can give you some feedback.
Yeah, sure.
I was writing it down. Let's one person. So one thing that I got hung up on, right, was when you mentioned about that 20 queries sent to the backend.
Yeah. Okay.
Right. So can you scroll up?
Okay.
Now, after you explained to me, I knew what you meant. But initially, when you just said that, oh, on an average, let's say I'm typing, the example you gave was something on the top, like, hey, I'm typing S, I'm typing A, I'm typing N, I'm typing space, I'm typing F. The queries are being sent to the backend. And I was like, why are you sending all the queries? Your client could say that, oh, this is actually matching the list I have. I'm not going to send any queries back, right? Because if I'm matching each and every letter, you don't want the client to send the backend any queries, because it's matching the words exactly, right?
Yeah.
Unless there has to be, they have some threshold of when they should send the query backend to the backend. But initially, when you said that, that was my reaction. I was like, I don't understand. And my as an interviewer, I might think that, oh, you're not thinking about the client side optimizations, right? Instead, I think you phrased it on the second time. You phrased it pretty well, which was like, let's just assume that each user sends 20 queries, right?
Yeah.
That's it.
Okay.
That's where it could end.
Okay, got it. Okay, yeah, that makes sense. Yeah.
Right?
Yeah.
Because we just started and I have no background about the problem, or I have no background where you're going with it. So
okay.
That was one thing.
Okay, that's a valid point. Yeah, that's a good point. Yeah.
Yeah, that's what I wrote. So mention about, either mention about client caching, like just make it as a pass by that, hey, I know we can cache on the client, but I'm assuming that the user is sending 20 queries, right? You can do that.
Okay.
Or just say that, let's assume there's 20 queries, period. And that's it, you're done.
Okay, got it.
The RDS, can you scroll down? I really liked that you explained table scan before I asked, because the moment you said RDS, I was my first thing was like, what about table scan? Because you're going to get a table scan on that.
Yeah.
So I think that was I think you mentioned that, and it just essentially says to me as an interviewer that, oh, you know what indexing and partitioning is. It gives me you know how to optimize on queries, right? It gives me that idea. So I'm not going to jump into that, because I assumed that, okay, you know table scan, you know row scan.
Yeah.
So scroll down. So so the next question I think I brought up, which was like, why did you decide on a brand new database? Did you consider text searching database or not? Maybe if you're doing this as a practice, I would say try to sweat the details, right? Try to find out, this is build versus buy. So building is always expensive.
Expensive, okay.
Right? Unless it solves a very specific scenario and it solves it very well, right? So
okay, got it.
when you're doing as a again, if it was a high senior staff engineer, my question to them would be, okay, why are you building this whole thing? Because this is going to be a nightmare to manage. Because right, so it's not only it's not only the sharding. You also have to start taking care of replication, right? And you also have to
So
start taking care
I
of
have a
fault
sorry,
tolerance.
Manil, I have a question. So in this case, I don't know the intention of the interviewer, right? Like, now, is he expecting me to look at the data structure, or is he looking at Elasticsearch, right? How do I approach that?
Yeah, so
How do I?
that's a very good question, and you have to probe the interviewer at that point. You won't get an answer, so you can, like, let's assume there is something that can solve it, right? If there's nothing that can solve it, then they're definitely looking for you to build something. But let's assume there is an option out there. So if you're doing this, like I said, you can say that, hey, I think a text searching database would fit this case well. Do we want to use an existing solution, or are we building something?
Okay.
Right.
Got it.
Or you can say that, do you want me? Just say that, and they'll probably tell you, like, we can use Elasticsearch, but I want to see how it works. So let's dive into that.
Okay, got it. That makes sense. Yeah.
So again, like, for very senior engineers, that's the question I would come. Like, how would you take care of replication, fault tolerance? All of that has to happen, right? Because that's the nature of distributed systems.
Yes.
How is this distributed? I think you answered. Mike, when you showed the try, I wrote it down, like, how is this sharded? And you answered that question. I liked the fact how you explained the try, how it worked all the way to the bottom. One thing that I thought you might miss, but you did not. Can you scroll up to your first try? Yeah, so this one, right? I thought that you would not explain that every search will result into all the way to the leaf node.
Leaf node, okay.
Right? But you did explain that, so that, I think that was a plus in my mind. That, again, that tells me that tries are very good for, like, dictionary searches, to say, oh, is tr present? Yes, it is present, right? Or is tree present? Yes, tree is present. But this is an autocomplete, so most people would just stop at the node where the word would match, or the letters input would match, but you went all the way to the leaf, so that was a plus for me. The real time was thing that I brought up, like, why can it not be real time? So what I would do is, what's that?
I'm sorry.
So what I would do is, I would ask for a scenario very specifically, right? Like, hey, is it Google search or is it Amazon search? Before you decide on real time or batching, make sure you know why you're building it, and also don't make an assumption that of what I said, that, oh, on Amazon, it's okay to update it later on. Just make sure you are on page with the interviewer before, like, and it's okay if that question comes when you are starting to design an aggregating service. At that time, you can ask, like, hey, are we looking for real-time update, or how late can we tolerate, right? And that way you can decide if it's a real-time or a batching system.
Okay, got it. Okay.
Yeah. One thing I would like to add here, like, if user mistyped something, so should we accommodate that?
So I don't think this accommodates fuzzy logic, right?
No, yeah.
The fuzzy matching is a complete.
You're saying, yeah, okay. I think the one thing I covered in the topic are we talking about this one? We said, like, no, we would always look for the prefix, right, rather than middle of the sentence or end of the sentence. I made that as a scope. I don't know if that would fit in that criteria. Matching support only beginning of the query.
Not quite. What I think is being asked is, like, instead of SAN, what if you type SON? So will it autocorrect and, like, give you suggestions of SAN? Assuming there are no words for SON, right? Like, there are less words for SON rather.
Yes.
So for that, hey Monal, just for that, we perhaps use like something like a Bloom filter that basically tells what are the used words so far, and if like a random word comes up, shows up, then like a fuzzy word shows up, then it doesn't match and just rejects it or something.
I'm not sure how Bloom filter would help, because Bloom filter just answers the question if this is present in the set or not, correct?
Okay, okay.
But there is a fuzzy logic matching algorithm. I'm not known to that. I know Elasticsearch does it, but I don't know how it does it. I do know Bloom filter answers the question like, hey, is this present in the set or not?
I mean, it would probably just do like a probability, right? What's the probability of this word being in the set, right?
Yes, correct.
Yeah, okay. Another question I had was, with respect to making it real time, if we combine the aggregation search with the query, would that make it real time? Like, so your search logs would get ingested with the input from the query, and there'll be, after you do the map reduce, there'll be something like a ranking service that will actually do the ranking and insert the data. So that would perhaps like make it little real time, right? Like, so basically combine these two diagrams together. I'm just putting out. I'm
Yeah,
not
yeah,
sure
yeah.
what.
I think so. Anytime you have map reduce, I just think of it as batching as opposed to real time. Because map reduce, like usually those jobs are pretty heavy in terms
Okay.
of at least the ones that I have worked with. We don't have map reduce jobs that run within like every 5 minutes or so. But if you have
Okay.
those, then that might work. But when you're getting to 5 minutes, I think you can have like Kafka stream support 2 hours, right?
Yeah.
So
Yeah.
you can have something like that, and actually the modeling, a combination of model and that service would be the way to go.
Got it. Okay. Thank you.
The one other suggestion, I think I already said it, but was always ask about approximation. Again, it depends on if you're like less than 5-6 years of experience, they're usually not expecting this from you. But if you ask, it's a bonus point. So like ask about like how much is like what is the user expecting. Always start with the user, because you have to start with your ideal product and then see what are the technical limitations, and make changes according to that. So if the user is okay with approximation, why not just do that. In my previous job, we had a MapReduce job which used to run for 6 hours because it used to find uniques in a set of 600 million items, right? So it was a very expensive job. Um, and the key question that I forgot to ask was approximation. I thought they wanted an exact answer. And then one day, and this was completely by fluke, I asked that person. That person asked me like, "Hey, what is the error rate on, this uniques that you're showing?" I was like, "There's no error rate. This is exact." They're like, "That's pretty awesome. We don't actually need that." And I was like, "What? I didn't know that." And then we made a change. We used a different algorithm for that, and the job basically reduced to 3 minutes. Period. That's it, right? And they did not care about it. So there was a massive change. So you always want to ask that. In aggregation service and such services, it makes a lot more sense. Recommendation engines, ranking engines, as opposed to like, I want your banking service, right? In banking service, you want an exact answer. And again, depending on your level, think about geo, like how do you geo shard, right? Think about replication, think about fault tolerance. Like this should, as you get senior, this should come more naturally to you. And again, when you design a database on your own, those are the biggest places of maintenance nightmares.
Yeah, that's a good point.
Awesome.
Yes.
Did you get good feedback? Did you get
It's
some
definitely a
actionable
lot of
feedback?
valid feedback. Monil is really helpful. Like, no, I just made a note of them.
Okay, awesome. I'm glad. If it's not helping, let me know, and I'll try to figure out what can help.
Yeah.
Okay, awesome.
Really good. Yeah. Anything else? Are we good?
I don't have anything. If anyone else wants to add something.
Yeah, I have a question.
Yeah.
So, yeah, when you have a white space, right? How are you doing the um trinode implementation when you have a white space?
Okay. I think that's the one Manil was talking about. We talked about two approaches, right? One is somebody talked about instead of going through the try node, we talked about like machine learning models. I think they're talking about, and the other approach is like we can have some delimiter, right? Like in this case, I could store it SAN for a space, to add some delimiter and put it in that try node, right? I can keep building this try node. A tree is like for that I could put some uh, character and then keep building it. Yeah, that's a quite challenging one. Yeah, I never thought, like, probably that's a good question. I'm going to do some research on that. Right. So that delimiter could be for anything, right? Like we could have a number of combination it could come in.
Um, yeah, and so Monet talk about like for the real time we using MapReduce. So it's just for estimate, yeah.
MapReduce is for batching. Real time would be more like Kafka streams.
Okay, so for Kafka stream, is that like estimate?
No, estimates. So whenever you want estimates or approximations, they're usually like Bloom filters or hyperloglog or machine learning models. It's always, they're all probabilistic. They will never give you an accurate answer. The system we have right now is giving an accurate answer. It will, when it says that best was, if you search VE, if it says best was searched for 50 times, that is very accurate. If you use approximation, it might say it's used 46 times, or it might not even tell you how many times. It might just give you a ranking, right? So, and there's no like, the way to prove that if it is 100% accurate would be basically running a massive job to do all those things, right? But does it answer the question?
So basically, if we put like a Kafka message queue for a real time, is it doable? Because there are so many queries coming in.
Sorry, I couldn't hear you.
Yeah, your voice is breaking. Like it's a little
Can
choppy.
you hear me? Can you hear me now?
Yes, now it's fine.
If we put Kafka message queue in it's for the real time, there are many like queries coming in. Is that doable for real time?
Sorry, I lost you on your question. I
Yeah.
heard that there are a lot of queries coming in, and then what is the question?
With message queue, can you do it in real time?
Yes.
And I think we talked about, right? One is instead of going to the logs, append only logs, probably we were talking about pushing to Kafka, and then we could have a job which basically looks at the existing try and then does some calculation to see, is it the new term, like is it popular than the existing one, it updates, right? Is it the approach we talked about, right?
Yeah. So is it the thing like aggregator thing? Is it the same as what we're looking right now? Aggregated data.
This could be a daily aggregate. This could be like every 5 minutes, what is the top trending, right? We can combine both and figure out which one is the top one, right?
Okay.
Yeah.
Okay, awesome. We're 10 minutes over time. I want to wrap this up. Thank you, Alex Angel, for your time. It was pretty awesome. This was a fun session. Tomorrow we have another session with Anshika, who's going to go over how to, update your LinkedIn and get noticed. I'm going to attend it. I don't know about you guys. It's at 3:30 p.m. PST or 3 p.m. Just check on the event schedule. I have a kickoff session coming up on the Saturday for the cohort that's starting on Monday. So if you want to join, the link is in the announcement. Uh, that's all it is. Thank you very much, everyone, for joining. I hope to see you all tomorrow.
Yeah,
Oh,
thank
and
you, Manil. Thanks for hosting this. Yeah.
yeah, absolutely. No, thank you again. And if anyone wants to present or anyone wants to solve a problem next week, just let me know. It's a great way for you to practice for your interviews. Can you explain your thought process to someone else, right? Uh, it's
Yeah.
so it'll help you quite a bit, and I will happily provide feedback. So thank you very much, Alex Angel. Really appreciate it.
Yeah. Thank you, guys. Yeah. Bye.